Hey guys, Bangy here and welcome to another statistics tutorial. In this video I'll be showing you how to calculate the transform probability density function using the cumulative distribution function method. This method involves firstly finding the cumulative distribution function of the probability density function. If you already have the cumulative distribution function, you can skip this step and I'll tell you when you can continue. So, as we might know already, the integral of the PDF is equal to the CDF, so we should take the integral of this function first. We have the integral of 4x 1 minus x squared dx, and this is a definite integral from 0 to 1. This information is not currently necessary. So we have for the integral of x 1 minus x squared dx, and this is equal to for the integral of x minus x cubed dx. This is equal to, if we do that, that is x squared, and then that is equal to 2x to the power of 2 minus x to the power of 4. And we do not need to do the c because this is a definite integral after all. Now the next step we want to do is we want to write out the CDF of this function again, which is fx is equal to 2x squared minus x to the power of 4. And this is for all x within the range of 0 and 1. And it's 0 elsewhere, as we have discussed earlier. We now know that the f of x is equal to the probability of that x is less than or equal to x little x, which is just a real number. We know that the f of y is equal to the probability that y is less than or equal to little y. And since the transformation variable we have is y is equal to x squared, we can now substitute y for x squared. And now we have the probability of x squared is less than or equal to little y. And what this means is that now we can convert this to the cumulative distribution function of f of x, and we do this by first square rooting both sides inside the probability measure, which is now the x is less than or equal to the square root of little y. And this right here, what we have here, can be rewritten. What it can be rewritten as is, it can be rewritten as the cumulative density function f of x evaluated at the square root of y, of little y. And what we can do now is we can now substitute this function. We can substitute the square root of little y into x there, and also x there, because we are evaluating this at the square root of y. And how we're going to do that is we're going to first write out the function again, the CDF. F of x is equal to 2 the square root of y squared minus the square root of y to the power of 4. And be very careful here. This might not change for this specific example, but you need to be aware that the range also changes. And in this case, the range changes to the square root of 0 to the square root of 1. So you need to be aware that that is now in the range of square root of 0 and square root of 1, and not just 0 and 1. But that's trivial for this question since the values remain the same. And we have 0 elsewhere. Okay, now what we can do is we can now simplify that. So now we have 2 to the power of y minus y squared instead of having it in square roots. And what we can do now is we can now differentiate this to get back the transformed probability density function. And how we can do that is we can just write out f of x, my apologies, f of x evaluated at y is equal to d dy, the f of x evaluated at y, which is equal to d dy 2y minus y squared. And that is equal to 2 minus 2y. And this can be factorized as 2, 1 minus y. And this is the answer. This here. That is the answer. Okay. So that is how we transform a probability density function for x 1 minus x squared, how we can transform that using the variable y is equal to x squared to get the answer 2 times y, 1 minus y. So I hope you guys learned something, and I'll see you next time in my videos.